one of your colleagues sent me a URL to an academic article, and I thought it would be useful to take a look at it because it's fairly typical of the structure of academic articles, and this might help you as you're doing your reverse outline and make your life a little bit easier. So it's about concussions and football. So let's go. This is going to the NIH, National Institutes of Health, and I mean, everybody knows about concussions in football, but as you start to scroll down on this, okay, so first there's an abstract, concussions and National NCAA, so I'm familiar with the football Division I. I'm feeling confident about that. That's fine. Alzheimer's, that's another thing that is fairly, I'm feeling like this is okay. Keywords, football, brain injury, CTE, chronic traumatic encephalopathy, fine. But then as we start scrolling down into the introduction, you would think that the introduction should be fairly easy to read. But, I'm scrolling down here, I'm like, concussion 3 to 3.74 per 1,000 AEs, like, this is typical of academic articles where there are abbreviations that occur throughout, for example, CTE. CTE is in common English, like NCAA, like those are acronyms or initials that we use in everyday language, like NFL. But within academic articles, it's really common that they have specific things that only occur in this field of study, or even in this article. So what I normally do is if it's a new term that I don't know, there will always be that abbreviation. It will always occur the first time they use it. They will spell it out completely, 1,000 athlete exposures, and then they typically define it with AE defined as one football player participating in one practice or game. So AE means you're playing football. And in fact, if I'm doing this, if I'm reading, like in my Adobe program, if you're reading in a program where you can make notes, right now I'm using Firefox, so I can't do it. I normally, for the first few times, like I copy and paste athletic exposure. I will copy and paste it so that every time I see AE, like I understand what that means, because otherwise you can lose the thread of what that actually means. Same with PCS. Copy it and paste it every time, or you can have like a running vocab list over here on the side. So if you might think you should read the introduction first. I think I went over this in class before we got derailed by COVID, but you'd expect when you're reading an article that you should read the introduction first. Introductions in academic articles are not necessarily to introduce a new novice reader to this topic. The introduction is really to show your audience that the authors have done their homework and they understand like the lay of the land, the research, the field of study, all the stuff they need to know to do the study that they're carrying out. So typically, when I start reading an academic article, the first place I go to is the very end, not the very end because that's the references, just before the end. So you could start with the conclusion. In this particular study, first they have a discussion and then they have a conclusion. So I would start with either the discussion or the conclusion, and then go and read the other one also. So let's start with the discussion. Usually it's easier to understand these. They tend to be in more average English. You do have to beware of when you jump to the bottom, you will find those acronyms and initials that I mentioned at the beginning. So if you see CTE and you don't know what CTE means, put it in there and it should take you, it should take you to the first time CTE in parentheses, and then you have it right, you have the meaning right there, and then you also have a definition right next to that. So, okay, let's get out of our find, go back down to the bottom to the discussion. And I don't have a background in medicine or anything, so if I can understand it, I'm assuming most other people can stand it. So about 10% of football players believe there's a possibility of dementia, CTE, Alzheimer's. Interesting. They're giving their ideas of what maybe this, their beliefs come from. Limitations of existing evidence, that's fine. These guys are, misunderstanding how likely it is to get injured. Pathophysiology, no idea. I mean, I have an idea, but I don't think that I know what that means. So you may be tripped up by words that you don't have definitions to, and you may have to actually go to the dictionary. Long-term health risks. Let's see. Perceptions will play a role in their behavior. That seems predictable. Important to recognize that either athletes overestimate or underestimate of the risk of concussion, and consequences may have unintended consequences. Fine. Overestimate of risks may lead athletes to inappropriately assume their personal ailments are resultant from concussion. You may think you whacked your head and that's leading to other problems. So this is understandable. I mean, kind of the most complicated area is like when they start talking about college sports right here. So in this discussion, they're talking about surveying college football players, and these college football players have impressions of whether or not they're going to get injured, have concussions, etc. So the athletes, this is intuitive. Athletes with a greater number of diagnosed concussions had greater odds of agreeing that there was a strong possibility of concussion-related risks in their future. So they think, if I've already had my head bashed in once, it could definitely happen again. Let's see. So they acknowledge limitations. This is good science acknowledges that we're not answering all of the things. You acknowledge that we have limited information, and then they give recommendations on what future studies should do. This is very typical of all sciences. So their conclusion is that a substantial proportion of these football players believe that they will sustain concussions while they're playing, and these could result later on in dementia, Alzheimer's when they're older. So these conclusions, I think, are fairly predictable. I think any of us could have guessed if you ask 100 football players what's going to happen if they play, we could have told you this. But that's our guess. These guys actually did a study and asked these people these questions. So this is their epistemologic data, meaning we are finding new knowledge. Maybe that's a new word for you. Epidemiologic. Sorry, I thought it said epistemic. Anyway, so now that you understand that the whole study is about football players' impressions of their short-term and long-term health effects from the risk of concussion, now you can go back and look at the abstract again. So abstracts are good in that you can briefly get a lot of information because they try to cover the whole study in a very short paragraph. The problem with an abstract is the same thing. They try to cover a lot of ground in very few sentences. So it's like it makes giant jumps from sentence to sentence. So it's like consider each sentence like one paragraph that's not necessarily connected to the next sentence in an abstract. So concussion we recognize as a risk in football. They examine the players' perceptions. What do these guys think of their risk of concussion, and then the consequences further on down the road. This is what they did. They gave these guys a survey for these NCAA athletes, and they give some of the results. 40% of these people believed X, Y, and Z. About 10% thought they might have dementia, Alzheimer's, etc. It makes, now that we've already read the discussion and the conclusion, it makes reading this abstract way easier. So the true incidence and prevalence of these outcomes are unknown. Like, more research has to actually, like, scientific, not just a survey about people's impressions, but, like, you know, studying people's brains needs to be developed. So now we go back to the introduction. This, keep in mind again, this introduction is both introducing the topic, but this is also proving that these guys have done their homework and they've reviewed the relevant other studies that are going to have an impact on their study. So, so read this as evidence of the author's understanding, not so much as a story. And so you can take the introduction for sometimes. Let me start over. Sometimes the introduction is relatively easy to understand after you've already skipped to the end of the story, like we just did. Sometimes it's still difficult to understand depending on how much you know about the topic. But even if you struggle with the introduction, don't give up. Once you hit methods, everything resets. So, like, the methods are usually quite easy to understand. It moves fast, but usually the concept is fairly easy. So we have NCAA, blah, 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 school's approach, blah, blah, blah. We talk to these people. We want to examine perception of concussions among these football players. Members of the target population, the same people who play. Convenience sample, that's an actual statistical thing, means the people that they were able to get their hands on, not like a randomly selected football player from all of the football players in the United States. They completed these questionnaires during that 1 year, and then they contacted like a year later probably. And so these are the people, 10% random each year. There's some statistical stuff on error rates. They tell you how they measured their opinions. They used a Likert or Likert scale. The person who made the scale pronounces his name Likert, but everybody calls it Likert because it sounds more normal. And you have probably done this, strongly agree. And this is how you get people's impressions of, you know, their opinions on stuff. And this is their statistical analysis. I recommend to everybody take a statistics class. It will change your life. You'll understand more about the world. And results. After we ran our statistical analyses, this is what the analysis tells us. A lot of times this can be dense, but you can just skip down. Sometimes you can look at the instrument that they use. The instrument in this case is their questionnaire, and they gave you their questions. This is what they asked the football players. If a football player can understand it, then you can understand it. And sometimes the tables are easy-ish to understand. When you see n equals, or n is around about 721 people. This is the number of people answering the question is about 431, subset of that 721. And let's see. And so, and then the way you understand this table is 183 people answered, let's see, 303 people answered that question, and then the percentage of those people is in parentheses. So that's 42% of the 721 total is how you read this table. So 303 people answered. That's 42% of the total sample. And change in risk, they describe a little bit about that. And let's see, you can kind of skip through here. Beta, in all my years of trying to understand statistics, I kind of understand beta, but sort of not. I know that's where it crosses your y-axis, but other than that, if anybody else can explain it to me, I'd be happy to sit through one more explanation. P-values means how likely is this to be to get a false positive. We can be sure at 0.0001. We can be quite confident that the data that they're getting from this study is not a mistake. It's not an error. Now, you could have errors in terms of the questions are not so good, and maybe they're misleading questions, but in terms of there being a statistical difference between one group of people that did not have these opinions versus this group of football players that did have these opinions, definitely those guys are different. It would be very unlikely for this to be just a random chance. So anyway, and then after you get through these tables, you get back to the discussion. And so if you read the discussion and you go back up to the tables, the discussion can oftentimes help you to understand the tables. This is true for medicine, psychology, linguistics, politics. It's true for lots and lots of fields of academic study. So I hope this has been somewhat useful, or it will be useful in the future. Thanks for listening.